Okay, so if you have two functions that you already know, given two functions, call one of them f and the other one g, then you can create new functions. So those new functions would be called f plus g, that's the name of the function, f minus g, fg, which is f times g of course, and f over g. So this is the function name, so f plus g you could plug x into, f minus g you could plug x into, etc. So you can get four new functions, and they're defined in the obvious ways. So f plus g, the definition of it is, well, you just take x and you plug it into f, take x and you plug it into g, and then you add the two outputs together. And the others are defined similarly. Okay, so the definitions are very intuitive. The difficult thing can be sometimes finding the domain, because you can't just take your final answer to find the domain. You have to realize that the x value has to be valid for f and also valid for g. So you have to take into consideration the two functions that are used to create these functions. So let's consider these two functions, f of x and g of x, and let's look at, for example, f plus g of x. This function would be f of x plus g of x, so you just add the two functions together. Very simple, just as you would expect. Okay? But now let's simplify this. They already have a common denominator, so you can just add the numerators and put them over the same denominator. And of course we know that 2 plus x is exactly the same thing as x plus 2, and when you divide anything by itself, they cancel and leave behind 1s. So this function equals 1. So f plus g of x equals 1. Now when you look at this and you want to find the domain, you would say, well, x can be anything because the output's just 1. There aren't any restrictions on this. But the problem with that logic is that we're not taking into account that x isn't truly just placed in here and given 1. It's plugged into each of these functions up here. So the step where you find the domain is the step where both functions are shown. So we find the domain in this step because it's the only step that shows in totality both functions. So to find the domain, we look at this step and ask for any restrictions. And we can see they both have fractions, denominators, and we know that the denominator, x plus 2, can't be 0. So the domain in this case is x can't be negative 2. So everything but negative 2 is in the domain of this function. F minus g of x is the difference. Which equals 2 minus x over x plus 2. This time nothing cancels, and so the function is this now. And to find the domain, we still use this step, and we'd see that x can't be negative 2 for the same reason as before. Fg of x is this function times this function, and you multiply straight across, and you get 2x over x plus 2. So here's the function. You still use this step to get the domain, and the only restriction is, again, that x can't be negative 2. Now we divide the two functions, and we get this, which is the same thing as this. Just rewriting it as division, now I can multiply by the reciprocal. And when I do that, I can see that the x plus 2's cancel, leaving just 2 over x as my final function. And to find the domain, I now have to use this step because it shows both functions in totality. So the denominator x plus 2 can't be 0, results in the same fact as before, that x can't be negative 2, but also the x over x plus 2 can't be 0. Multiply both sides by x plus 2 to clear the fraction, and we end up with x can't be 0. So we have two restrictions on this domain.